Okay, so again today we're looking at simplifying trig expressions using our identities. Okay, I like these. Not everybody likes these, but I like these because it makes me think. So, a couple of things. One, if you want to write this down, great. One is normally I try and change things to signs. So change to sines and cosines. Okay, that usually helps me quite a bit. And then to change things to sines and cosines, I've got my identity sheet, right? My identity sheet shows lots of sines and cosines, right? Lots of sines and cosines. And the second hint is anytime I see a squared term, if I see a squared term, any trig square root of theta, I look for my Pythagorean identities. Okay. That's usually how I tackle these, okay? Because once I get things down to sines and cosines, then things kind of happen for me, okay? So if I take a look at number one, I've got cotangent and tangent. Cotangent and tangent. You see? Sines and cosines, right? See that? Cotangent, tangents. And I've got a 1 plus tangent square, so if I got a squared term, I'm going to look at my Pythagorean identities, and 1 plus tangent squared is an identity, isn't it? Okay, so let's see if I can take what I have here and rewrite it and see if this makes any difference, okay? So, let's see. First of all, let's change cotangent and tangent. So I'm going to write cotangent. My identity says cosine of a sine, so I'm going to write this one as a cosine A over sine A. Tangent, okay, my tangent identity is sine over cosine, okay, so I'm going to go sine A over cosine A, okay, and then I saw, as far as a trig identity, my Pythagorean identity, I saw a 1 plus tangent squared, right? That's a Pythagorean identity. And I've got my 1 plus tangent squared is equal to a secant squared, okay? Let's see if that's going to help much, okay? Times a secant squared of A, all right? Again, I want to change things into sines and cosine. I know secant is 1 over cosine, okay? So secant squared would be 1 over cosine squared. All right, so let me keep writing this. And I'm going to invert and multiply here. You guys okay with that? Invert and multiply here. So I'm going to flip, because I'm dividing. So I'm going to flip. I'm going to go cosine A sine A times, invert and multiply, right? Cosine A times a sine A, and then times a 1 over a cosine squared. Okay? Alright, so let me back you up so you kind of follow what I'm doing. Okay, change things like sines and cosines. Cotangent, cosine over sine. Tangent, sine over cosine. But I got a fraction divided by a fraction, so invert and multiplied, right? 1 plus tangent squared, I found in my identities as secant squared. But secant squared, again, back to sines and cosines is 1 over cosine squared. Now, do you see something? I'm really hoping you see something. You see something? Yeah, you got cosine. That's a cosine squared. Do you guys agree? That is a cosine squared. It's got cosine to a cosine squared, right? You okay with that? How that would cancel? Because that is cosine times cosine, which is a cosine squared over a cosine squared. Cancel, cancel. So then what am I left with? Well, I'm left with a 1 over a sine squared of A And a 1 over sine is a cosecant, isn't it? 1 over sine is a cosecant. So I'm going to rewrite this as a cosecant squared of a. And that's the simplest version we can get. So we took this ugly mess and made it into something nice and tidy. Okay? All right? Example 2. How am I doing, okay? Example 2 is going to actually be an algebra problem first, okay? So let me do a little side work. If you had y cubed plus y times x squared, okay, just algebra, just plain old algebra. Do a little side note. We, in algebra, would factor out a y. You guys agree? We could common factor, we're going to common factor out of y, and I'd have y then times a y squared plus x squared, okay? Right? We've done that before. Well, we're going to do the same thing over here, except for instead of y, we're going to take out a common sign. They both have at least a sine theta in common. Do you see that? Let's see how that's going to help. If I take out a sine, take out a sine, so if I take out a sine theta out of both terms, I had a sine cubed. If I take out a sine, I'd have a sine squared. If I take out a sine, I'd have just a cosine squared theta, okay? Now, if I have a square term, any trig squared, I look for my Pythagorean identities, right? So I look for my Pythagorean identities, and lo and behold, what is sine squared plus cosine squared? It is 1. So this just becomes, this just is 1. So I'm going to have a sine theta times 1, which is just sine of theta. Simplifies down quite a bit, doesn't it? Am I doing okay? Okay, these are hard, aren't they? Or else they're easy and you love them and they're fun. But I just have a sick mind. I know, Zoe, I have a sick mind. So it is what it is. Okay, example 3. All right. Now this one definitely has a trick. This piece is easy. Hopefully, let's do this. Let's take, this is easy. Because what is cosecant? Do you know what cosecant is? Take a look. Take a look. What is cosecant? Anybody see it? What is cosecant on your sheet? 1 over sine. So you got sine with 1 over sine. That's easy. Let's do that, okay? Let's do this. Let's do this first part here. Plus sine of x. And then, nice job, Spencer. I know cosecant is 1 over sine, so at least that's going to be easy. Sines cancel, right? Cancel, cancel. Boom, boom, and I get 1, okay? How's that? Now, when I see a square term, right? When I see a square term, I'm thinking I might want to look at my Pythagorean identities. So cotangent squared is equal to, there it is, cotangent squared is equal to cosecant squared minus 1, okay? Well, let's see how that's going to help. So I'm going to change the cotangent squared into a cosecant squared x minus 1 over a 1 plus cosecant of x, okay? Now, up above, I'm going to do a little bit of algebra, which, of course, you guys know how to do algebra. If I had x squared minus 1, I wanted to factor x squared minus 1. X plus 1, x minus 1, right? I want to factor x squared minus 1, x plus 1, x minus 1, right? The difference is, instead of x squared minus 1, it's cosecant squared minus 1. So I'm just going to do this. I'm going to factor this. So it's factor this one like I factored up here. Oh, I forgot what one there. Except for instead of x, we'll do cosecant. So we write this as a cosecant of x plus 1, a cosecant of x minus 1 over a 1 plus cosecant of x, right? And then hopefully you see what we're going to do. Cancel, right? You can cancel a cosecant of x with a 1 plus 1 with a 1 plus. Those are the same. cosecant of x plus 1 is the same as a 1 plus a cosecant of x. So let's see what we have. So if that cancels, then I'm left with a cosecant of x minus 1 plus 1. Now, of course, the 1's cancel. Boom, boom. And I'm just left with a cosecant of x, which is a lot simpler than the original trig. We went from this to this. Same exact question, but much simpler, okay? Yes, Faith. Go ahead, ask. I can't.
I was just going to ask you something about that.
You sure can, yeah. So, let me go ahead. Homework today is, and I'll work with you, page 321, 13 to 22 all, and the exercise 24.